Hi everyone, now I am discussing coordinate geometry. So what is meant by coordinate geometry? Discussing the geometrical ideas with reference to the coordinate system. Imagine it's a plane, the plane divided into four equal parts. So by the axis, which is I am considering the x-axis and y-axis. So this is y-axis. This direction is called positive x-axis. This direction is called negative x-axis and indicated as x dash. So this direction is called positive y-axis. This direction is called as negative y-axis, indicated as y dash. The intersection part between the x-axis and y-axis together is called as origin and indicated as 0, 0. If any point or any location I want to indicate in a plane, you just follow like this x, y. What is x and what is y? So where x is called abscissa, and where y is called as ordinate. And abscissa is also called x coordinate and y is also called y coordinate. Suppose if I indicate the points here 0, 0, towards right hand side is called positive numbers such as 1, 2, 3, 4, 5 and so on. Origin, if I take above numbers, so which is positive again, this is y axis positive, 2, 3, 4, 5 and so on. Below the x axis, again we have a negative y axis such as -1, -2, -3, -4 and so on. Here from the origin left side again minus, but this is x axis negative, so -1, -2, -3, -4, -5 and so on. Suppose if I want to locate any particular location, just imagine this is the location I am indicating. If this is a location, just write this point as, so this is 5 units traveled from the y axis and 3 units traveled from the x axis. So this location is just write as 5, 3. If I locate the point 5, 3 on a plane, so 5, 3 means both are positive. So in the first quadrant both are positive, plus, plus. If I indicate in the second quadrant, so x is negative, y is positive. So negative, positive. In the same way, y coordinates and x coordinate located in third coordinate system. If any point located in third coordinate system, x is negative, y is also negative. So negative, negative. In the fourth quadrant, x is positive direction, y is negative direction. So positive, negative. So this is the how we'll indicate a points. And in this, if x coordinate is considered, distance from y axis we will say. If y coordinate is taken, so that is distance from x axis. So very simple. So x coordinate is taken, distance from y axis. If I take the y coordinate is distance from x axis, which is very oppositely. So if I say distance from 2 units distance from y axis and 3 units distance from x axis, how to indicate a point? Remember, distance from y axis is x coordinate, distance from x axis is y coordinate. So this point I can write it as 2, 3. Okay, I hope everyone is clear. Now from this topic we'll just extend the topic. Okay, let us move for the next topic, which is distance formula. So distance between any two points, let us consider A is a point x1, y1 and B is a point x2, y2. So distance between these 2 points, so I am not going to explain with the proof actually. So just remember the formula where AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. If you need the proof, so please comment in the comment box. So in the next video definitely I'll explain the proof. So by using the distance formula, what we are going to do? in this chapter. So let us say by using the distance we can find the types of triangles. So just indicating the types of triangles. How can you differentiate by using a distance formula? Let us indicate the triangle ABC, just naming as triangle ABC. So where the sides are AB, BC and AC. If all these three are equal, what we called equilateral triangle. If any two are equal, let us say AB is equal to BC, which is not equal to AC. Otherwise, here three possibilities I can say. AB is equal to AC, which is not equal to BC. Next, AC is equal to BC, which is not equal to AB. If out of these three any one is possible, that way I can say that two sides equal. If two sides are equal in any particular triangle, this is pronounced as isosceles triangle. Isosceles triangle. And the third type, just indicate like any two sides not equal. AB is not equal to BC, which is not equal to AC. If all three are not equal, so we can say that scalene triangle. Scalene triangle. Again I am repeating, so please observe very carefully. If all three sides are equal, we can say that equilateral triangle. Any two sides equal which is not equal to third side, there are three possibilities we are going to check, then it is called isosceles triangle. So no two sides are equal, that is called a scalene triangle. This is a type of triangle based on sides. Suppose if I know the type of triangle based on angles, if I want to know, then what to do? So let us see, which is by using the distance formula only. Again triangle I am drawing. Let us imagine it's a triangle ABC is again ABC. So there are three different triangles based on angles. So first one we can take it as acute angle. So second one is right angled. And third one is called as obtuse. How can you decide whether it's acute angle triangle, right angle triangle or obtuse angle triangle? So by using a distance formula again. So let us find the first distance formulas. So let us say AB is a side, BC is a side and AC is a side. So just square it. Here squaring. Sum of squares of any two sides is greater than the third side. So which again have three different possibilities, such as AB square plus AC square, which is greater than BC square. Otherwise AC square plus BC square, which is greater than AB square. If any one of these is possible, that type of triangle is acute angle triangle. Okay, the next possibility, sum of squares of any two, AB square plus BC square, which is equal to third side square. Again three more possibilities I can say, where AB square plus AC square, which is equal to BC square. Otherwise we can say that BC square plus AC square is equal to AB square. If any one of these is possible, we can say that type of triangle is a right angle triangle. And how to choose obtuse angle triangle? So in this, sum of squares of any two sides is less than the third side square. So which means AB square plus BC square is less than AC square. Otherwise BC square plus AC square is less than AB square. And the third possibility is AC square plus AB square, which is less than BC square. If any one of these is possible, that type of triangle is obtuse angle triangle. I'll repeat again. First statement, Sum of squares of any two sides is greater than the third side square, that is acute angle. Sum of squares of any two sides which is equal to third side means that is a right angle triangle. So this is also called Pythagoras theorem. So third condition is sum of squares of any two sides is less than the square of a third side. So we can conclude that it's an obtuse angle triangle. I hope you are clear. So again, by using a distance formula, how to conclude a collinear points. So now the topic is collinear points. Okay, so let us say three different points are given. A is equal to 1 point, B is another point, C is another point. If these are the three different points, so how can we prove the collinear points? By using a distance formula again. So just find the three different sides such as AB, next BC and next AC. Here you have to make sure that A, B, C are irrespective of indication. So we can take like A is any point in the given data and B is also any point on the given data and C is also any point on the given data. So that's why we just take the three possibilities again. So sum of any two sides AB plus BC which is equal to AC, otherwise AB plus AC is equal to BC, otherwise. So BC plus AC which is equal to AB. Any summation of two different sides is equal to third side, which can say that they are collinear points. If not, they are not collinear points. First, what is meant by collinear points? If a points you taken, all the points are located in the same line. Okay, the points are called collinear points. Okay, so let us take an example to understand better. Let us consider AB is equal to 5 units, BC is equal to 7 units. Suppose if I got AC is equal to 12 units. Now observe very carefully, 5 plus 7 we are getting 12. So A is this location, B is this location and C is this location, imagination. If I take this location distance 5 units and the distance from this point to this point is 7 units. So now these are the points are A, B, C locations. AB is equal to 5 units, BC is equal to 7 units. Then AC together added 12 units came. So that's why. So the summation of two different measures, this will become the third measurement. So that points are forms a collinear points. So that points if you join, that always forms a one straight line. So the points always in the same straight line, the points are called as collinear points. I hope everyone is clear about the collinear points. So let us solve by using a distance formula how to indicate or how to decide different type of quadrilaterals. Now I am checking the quadrilaterals. So especially in the coordinate system, so mostly we will discuss about four different quadrilates, such as first one is square, second one is rhombus, third one is a rectangle, and the fourth one is parallelogram. And the fourth one is parallelogram. Okay, how to decide whether it's a square, a rhombus, a rectangle or parallelogram? Let us draw a rough diagram to understand better. So let us imagine it's a quadrilateral generally. So A, B, C. So we are not very sure about whether it's a square, rectangle, rhombus or parallelogram. So just we'll find the type of sides only. So just find the sides AB, BC, DC, AD. Okay. Here we can easily segregate AC is a diagonal and BD is also diagonal. So here these are the sides, okay, and the diagonals AC, BD are the diagonals. Okay, I hope everyone is clear. Sides and diagonals. There are two criteria we can observe very carefully. In squares and rhombus, all sides are equal. In rectangle and parallelogram, opposite sides are equal. That is very sure everyone, I hope. Understood clearly? So now we'll segregate two categories. All sides equal, opposite sides equal. Okay. If all sides are equal, which can be represented AB is equal to BC is equal to DC is equal to AD. In this, opposite sides are equal, which means AB is equal to DC, BC is equal to AD. I hope everyone is clear. And so how can we differentiate either square or rhombus? So in rhombus also all sides are equal, square also all sides are equal. But the special property in square, diagonals equal. But coming to the rhombus, diagonals not equal. Okay, by this property we can segregate whether it's a square or rhombus. If all sides are equal, there are two possibilities, either it's a square or rhombus. If diagonals equal, which means AC is equal to BD, then it is a square. So we can very surely say that it's a square. If suppose all sides are equal but AC is not equal to BD, diagonals are not equal, so our option we should take it as a rhombus. Okay, coming to the second possibility. So opposite sides only equal, which means AB is equal to DC, BC is equal to AD. So again there are two possibilities, either third condition I am taking, either it's a rectangle or it's a parallelogram. Okay, then how can we segregate whether it belongs to rectangle position or it belongs to a parallelogram shape? So again it decides the diagonal. So in rectangles, diagonals are equal, AC is equal to BD, and in the parallelogram diagonals not equal, AC is not equal to BD. Okay, again I am saying, please listen carefully. First of all, we should find all the different type of sides. If all sides are equal, we can eliminate two options. It's not a rectangle, it's not a parallelogram. There are two possibilities, either it's a square or rhombus. In that, if diagonals are equal, we can eliminate the rhombus and that will be a square. If diagonals are not equal, we can eliminate the square and it will be a rhombus. This is a criteria. And one more thing, only opposite sides are equal and adjacent sides are not equal. Adjacent sides means, here I can say BC not equal to DC. For example, two adjacent sides, this side is not equal to this side, so adjacent sides not equal. And again two more formulas, and again two more possibilities, either it's a rectangular shape or parallelogram shape. If diagonals are equal, it's a rectangle. If diagonals not equal, it's a parallelogram. I hope everyone is clear. So let us move. The next topic is section formula. So section formula, again proof I am not explaining. If you need proof, please comment in your comment box. So now in the next video definitely I will explain the proof. Okay, so section formula, let us imagine the criteria. There are 2 points A and B. So where A is a point x1 comma y1 and B is a point x2 comma y2. Let us imagine the P is a point dividing the line segment P is x comma y, dividing the points in a sum ratio, that is m is to n. So then the point P can write it as Px comma y, which is equal to mx2, so means m into x2 plus n into x1 by their addition, so m plus n, comma my2 plus ny1 by m plus n. This is called internal section. If the section is outside, so just the same formula we write it as mx2 minus nx1 by m plus n, sorry, m minus n, comma my2 plus my2 minus ny1 by m minus n. If negative is written, it is called external section. If plus is written, this is called internal section. So in CBSE, this external section is not there. So please focus on internal section only thoroughly. Suppose in the same criteria, if m is to n, so m is to n is a section ratio, both are equal. If m is equal to n, what happens? So m is equal to n means section ratio will be m is to m, and the m cancel, 1 is to 1. If the section ratio is equal, and this is called a midpoint formula. How the midpoint formula can be changed? So now identify m is equal to 1 and n is also 1. So by replacing, so 1 into x2 plus 1 into x1 by 1 plus 1, comma 1 into y2 plus 1 into y1 divided by 1 plus 1. This simplification can be done like this one. So x2 plus x1 divided by 1 plus 1 is 2, comma y2 plus y1 divided by 2. So this is called midpoint formula. Midpoint formula of a given two different points. Okay. So by using this, we can do many questions in this exercise. Last topic. So that's point of trisection. Point of trisection. What is meant by point of trisection? So let us imagine a criteria. There is a line segment AB. So AB are the two different points, x1 comma y1 is a 1 point and the B is considered as x2 comma y2. I need the line segment AB divided into three different equal parts. So which can be named as, let us consider the point P1 and another point P2, which divides the line segment into three different equal parts. Equal means what? Measurement wise equally. Okay, same measurement means in a ratio wise, this is one part and it is also one part and it is also one part. Then it is very quite similar to the section formula. So where we can consider m is equal to one part and n is equal to this addition is two parts. So therefore case 1 I can consider as m is to n is equal to 1 is to 2. If I want to find the for P2 as a location, P2 as a location, here is 1, here is 1. These two addition is two parts, here is one part. So I can take case 2. In case 2, we can consider as m is to n ratio, which can be start with 2 is to 1. Okay. Case 1 use the value 1 is to 2, case 2 use the value 2 is to 1 and use the same section formula, and two different points you will get, that is point P1 and the second case point P2. So these 2 points are called point of trisection. In the same criteria, if I need the line segment divided into either 4 parts also, let us imagine 4 parts. This is A and it is B. 4 different parts means I will get P1 and P2, P3 I will get, means 1 is to 1 is to 1 is to 1. Then how to do these type of criteria? So let's you take here one part, these all added now 3 parts. So case 1 I can consider m is to n is equal to, I can consider as 1 is to 3. Okay, second case I will consider as here these two parts and these two parts. So take these two as together is 2 units and these two you take it as 2 units, and 2 is to 2 means I will get 1 is to 1. So where m is to n is equal to 1 is to 1, which means I can apply midpoint. Okay, remember this is a midpoint. Second point P2 we will get it as by applying a midpoint of A2 and B. Third criteria, I will take these 3 locations, identify these 3 locations 1 plus 1 plus 1. So I will take the m is to 1 in case 3, so we will get it as 3 is to 1. So then by applying these 3 different cases where m is to n is equal to 1 is to 3, 1 is to 1 and 3 is to 1. So we will get 3 different points such as P1, P2, P3 locations,